C1d, making polymers. So a bit of recall here from an earlier module. We're going to make alkanes and alkenes. We're going to meet those again. Alkanes, if you remember, came from crude oil. Alkenes were made during the cracking process. So you have to remember that an alkane has a formula of CnH2n plus 2 and an alkene is CnH2n. So an example I put here, ethane is 2 carbons and we've got 6 hydrogens, but ethene has got 2 carbons and only 4 hydrogens, but it has the special thing of a carbon-to-carbon double bond. Alkanes can be called saturated because you cannot add anything else to it. Every bond of the carbon is full, whereas alkenes are unsaturated because we have this carbon-to-carbon double bond. These could break open and form a structure like the alkane. The test for an alkene is it decolorizes bromine water. So if we have an alkene in a test tube and we put some bromine water in, which is an orangey colour, and we shake it, it'll become clear and colourless. So this is an addition reaction. Basically the bromine adds onto these bonds and makes a colourless dibromoalkane. So instead of 2 of these hydrogens, we'll have 2 bromines stuck across, but it'll become saturated then because there'll be no spare bonds. Now we'll have a quick look at the process of polymerization. In this process we're joining lots of monomers into a chain. A monomer, as an example here, is an ethene molecule. So it has a carbon-to-carbon double bond which could break open, as we said up here, and join together to make a chain. So when they all join together it's called a polymer, and we need high pressure and a catalyst to squeeze all of these monomers together to make a polymer. Now here's an example of the polymer. We've now gone from ethene to polyethene, which we know as polythene, and we draw it like this. The carbon-to-carbon double bond has now disappeared. Instead we've got these wiggly lines outside the brackets, and what that's saying is there are n numbers of this repeating unit in a chain, and this could be hundreds or up to tens of thousands of carbon atoms long.